Hello everybody, welcome to this session on prescriptive analytics. Today we are going to be studying association rule mining using the Apriori algorithm. This is part 1 of the lecture where we will discuss the algorithm and the main terminology involved. So what is data mining? Data mining refers to the extracting or mining of knowledge from large amounts of data that corporations gather, and they need some sort of representation of knowledge to come out from that data. Data mining should have been more appropriately named knowledge mining, as we are actually using the data as a source for the knowledge, and knowledge is what we gain out of this data. So we are more of mining knowledge rather than data. Data mining is one of the steps in knowledge discovery. Knowledge discovery as a process is depicted in this figure. It consists of an iterative sequence of the following steps. We first clean the data using data cleaning techniques. Integration of the data is then done. Parts of the data are then selected and transformed as per the needs of the organization, and then we use data mining, which is going to be focusing on to arrive at knowledge from the data, and then we have several methods of representation and evaluation of that data. So this is a useful diagram. Let's take note of that. Now we come to the concept of frequent patterns. These are the patterns which occur frequently inside a database. For example, if a person is buying something such as milk, very often tied with bread, so that means somehow milk and bread are frequent patterns that come together, and the seller of the milk and bread might want to know this so that he shelves them together in the shop. So a set of items that appears frequently together in a transaction data set is a frequent item set. Finding such frequent patterns plays an essential role in mining associations, correlations, and many other interesting relationships. This field has become more and more important just because analyzing relationships between purchased goods can help increase the amount of goods sold. Which brings us to our next topic, which is market basket analysis. A market basket analysis is just a term used for representing exactly what I have just explained. So whatever a person puts in his basket in a market is somehow related. The items he is buying are somehow related, and we want to know that how many such rules we can form that if a person is buying an item, then he is also buying another item. So this association can help us understand the relationship between the items we are selling and how often they are bought together, and therefore what discounts, coupons, etc. that the seller should propose. A typical example of a frequent item set mining is market basket analysis. This process analyzes customers' buying habits by finding associations between the different items that the customer places in his or her shopping baskets. Each item has a Boolean variable representing the presence or absence of that item. 0 would represent the absence of that item and 1 would represent the presence. The Boolean vectors can be analyzed for buying patterns that reflect items that are frequently associated or purchased together. These patterns can be represented in the form of association rules. For example, people who buy computers generally buy antivirus software as well. So we can create an association rule such that computer implies an antivirus, A implies B, such that when a computer is bought, then B, an antivirus, is also bought. So support and confidence here are mentioned but have not been explained yet. We'll be focusing on these later on. So what is an association rule in terms of definitions? Let I be a set of items containing I1 to IM items. Let D be a database of transactions where each transaction T is a set of items such that T is a subset of I. Let A be a set of items. A transaction T is said to contain A if and only if A is a subset of T. An association rule is an implication of the form A implies B, where A is a subset of I, B is a subset of I, and A intersection B is equal to phi. The support of A implies B, such as the one we said computer implies antivirus, is the frequency of that item in the dataset. The frequency of A union B in the dataset. That means how often has the computer and antivirus been bought together. The confidence is the probability of buying an antivirus given that a computer has been bought. Generating association rules is our next topic. Coming to that, let's take an example. Suppose that the data contains the frequent item set I1, 2, and 5. What are the association rules that can be generated from I? The non-empty subsets of I are I1, I2, I1, I5, I2, I5, I1, I2, and I5. The resulting association rules are shown. So the different rules that we can form are, we pick any two out of the three items and then associate that with the buying of the third item, or we choose any one item and associate that with the buying of the other two. So I1 and I2 can be associated with I5, I1 and I5 can be associated with I2, and similarly for the other four. The single components like I1, I2 and I5 can be associated with the complement, and such that I1 is associated with I2 and I5, I2 is associated with I1 and I5, I5 is associated with I1 and I2. These are all the associations which are possible. Some of these will be pruned out later on and will not result as part of our rule base. Say if our minimum confidence threshold is 70%, then only the second, third, and last rules above are output, because these are the only ones generated that are actually strong rules. Note that unlike conventional classification rules, association rules can contain more than one conjunct in the right hand side of the rule. Association rule mining can be viewed as a two-step process. First, we need to find all frequent item sets. Second, we need to generate strong association rules from the frequent item sets. Now, let us focus more deeply on what is support, what is confidence, and what is lift of a rule. Let us say we have a rule of the form x implies y. The support of x implies y is the frequency of x union y in our database which has size capital N. So support would be the frequency over N. Confidence, on the other hand, would mean what is the probability of getting a y, what is the conditional probability of getting y, given that x has already been observed, x has already been bought, and what is the probability of buying y. Note that here we are taking example of buying because it is market basket analysis, but the same concept applies to other fields as well. So the confidence, if you work it out in math, the conditional probability comes out to be frequency of x union y upon frequency of x. The lift turns out to be, the lift of a rule represents the ratio of the discovered support to that expected if x and y are independent. So it would turn out to be the support over the support of x multiplied by the support of y. The Apriori algorithm. Now let's come to this algorithm which will help us find the frequent sets. Apriori is a seminal algorithm proposed for mining frequent item sets for Boolean association rules. The name of the algorithm is based on the fact that the algorithm uses prior knowledge of frequent item set properties. Apriori employs an iterative approach known as a level-wise search where k item sets are used to explore k plus 1 item sets. Don't worry if this is not clear right now. We will take an example further on which will make this very much more clear. Now, let us focus on one very important property of an item set. If an item set is frequent, then all of its subsets must also be frequent. It's very intuitive, as if we are observing a set very often in our database, then that also means that all of its subsets are being observed at the same time. This is the same thing that has been represented in the lattice form. And if, for example, CDE is a frequent item set, then CD, CE, CDE, all of its subsets are also very frequent. Now let us come to a stepwise discussion of what the Apriori algorithm actually does. So we apply minimum support to find all the frequent sets with k items in a database. We use the self-join rule to find the frequent sets with k plus 1 items with the help of frequent k item sets. We apply this pruning in a loop and keep on pruning the data and increasing the size of our sets until we actually reach a point where the size of the set is so big that there is no data item matching that set and it results in phi output. Do not worry again if this is not clear at this point. When we take an example, it will be much more clear. Now let us examine the pseudocode superficially for the Apriori algorithm for discovering frequent item sets. Note, D is a database of transactions. Minimum sub is the minimum support count threshold. Let us examine the method now. L1 is iteratively found out from the database, and for k is equal to 2, we start doing this process until lk-1 turns out to be 5. So we generate the candidate set for the next one, for the next C. For example, let's take k is equal to 2, and C2 is generated from a priori gen function having the input L1 rather than L2. So when we generate C2, we do it from L1, and when we generate L2, we do it from C2. So this process continues until we get that the minimum support cannot be any longer satisfied by the sets that we get. So let's take a look at these functions, which will be much clearer when we take the example from the next slide. So here in this table we have transaction IDs on the left and list of item IDs on the right. So transaction 100, for example, had the purchase of items 1, 2 and 5, 200 had the purchase of 2 and 4. So the steps involved are, in the first iteration of the algorithm, each item is a member of the set of candidate 1 item set C1. The algorithm simply scans all of the transactions in order to count the number of occurrences of each item. That table is given here in the first table. Each item from item 1 to 5 is given with its support count, that is its frequency, and then we prune out the ones which do not satisfy our minimum support. Here all of them seem to be satisfying, therefore none of them is pruned, and C1 is equal to L1. Later on, this process is then carried out, now producing C2 from L1 by taking L1 cross L1 as denoted in steps 3. To discover the set of frequent 2 item sets, L2, the algorithm uses the join L1 cross L1 to generate a candidate set of 2 item sets, that is C2. Now C2 will be generated as L1 cross L1, and L2 will be generated from C2 by applying the same pruning that we did here. So do not get confused by this. It is a very simple process, and focus on the figures here. So C2 is generated as I1, I2, I1, I3, I1, I4, I1, I5. Since I1, I2 has already been examined, then we take I2, I3, I2, I4, I2, I5. Then since I3 has been examined with 1 and 2, then we start with 3, 4, 3, 5. And since 4 has been examined with everything above, so 4, 5 is the only one left. So this is our C2, and the support counts are counted from the database very easily, and these are then compared with the minimum support counts given, and this results in L2. Similarly, we carry out the process until we get to step 8, wherein C4 turns out to be 5, and the algorithm terminates having found all the frequent item sets. The ones left in L3 are therefore our item sets which are frequent. Now, having understood how the Apriori algorithm actually discovers the frequent sets from a database, what are the applications of ARM? We have discussed market basket analysis, where we examine a database to find out which purchases are made frequently and therefore find out the frequent item sets. There are many other places as well in which ARM is applied. For example, in medical diagnosis, we use it for applying association rules that can be used for assisting physicians to cure patients. It helps to identify the probability of illness in a certain disease. The application of data mining techniques to census data and more generally to official data has also gained popularity recently. And some other applications include applications to protein sequences in biology, where they are used to find out frequent patterns among DNAs and their genes to see which ones are related to which other ones and what traits would therefore be important in an individual which already has certain traits. And CRM of credit card businesses, yes, the collective application of association rules techniques reinforces the knowledge management process and allows marketing personnel to know their customers well to provide better quality services. So as we have seen, ARM has turned out to be a very successful technique for finding out frequent item sets, and which is in turn necessary for the formation of rules which help different field managers to figure out how to best sell their products. If one of the product is related to the other product, then they have to be sold together. They have to be given incentive to be bought together because these are items which people are generally interested in together. So using these techniques, there's a lot of scope for managing your inventory better. So take note of that, and thank you. This lecture is concluded right here. For any clarifications, please feel free to contact us at innovation@ictsscience.com or director@ictsscience.com, and thank you.